chain rule applies when you have one function inside another. So two functions that are composed, or you could think they're applied as sort of a chain. First one function and another. This is a function where we start with x, we plug it into g, whatever comes out of g, we plug it into f. That's a chain or a composition. Chain rule says that you take the derivative of the outside, so find df dx, but evaluate it at the inside. So plug in the inside function, then multiply that by the derivative of the inside. If you write it with that Newton's notation, which involves using primes, you get f prime at g times g prime of x. For example, if someone asked you to find the derivative with respect to x of the sine of x squared minus 5x, you take the derivative of the outside. The outside function is sine, right? So you think the outside function is the sine of x, and the inside function is, in this case, x squared minus 5x. The derivative of the outside is the derivative of sine, which is cosine. The derivative of the outside evaluated at the inside would be the cosine of x squared minus 5x. Since g of x, the inside function, is x squared minus 5x. The derivative of the inside would be the derivative of x squared minus 5x, which is 2x minus 5. So we put this all together, we get f prime at g times g prime. That would be the cosine of x squared minus 5x times 2x minus 5. Or you could turn this around, we have 2x minus 5 times the cosine, I'm not sure where I got that, cosine squared. Anyway, 2x minus 5 times the cosine of x squared minus 5. Let's maybe do one more example. A special case is when you have some function raised to a power. So in our case, the outside function is a power function. We know the derivative of a power function. The power comes down and you get x to 1 power less. So the derivative of the outside evaluated at the inside would be then n times g of x to the n minus 1. So this is going to give us n. Derivative of the outside evaluated at the inside would be n times g of x to the n minus 1 times the derivative of what's inside, but the inside function g of x, its derivative would be g prime of x. Or in Leibniz notation, that's n g of x to the n minus 1 times the change in g with respect to x. For example, if we needed to take the derivative with respect to x of a function like x squared plus sine x cubed, the chain rule says you take the derivative of the outside. The outside is the cubing function, so the 3 comes down. You get the inside to 1 power less, and then you multiply by the derivative of the inside, which is 2x plus cosine x. So for the derivative here, we have 3 times x squared plus sine x squared times 2x plus cosine x.